so go ahead and throw your name on here, even if you glued it in. It makes it easier when I'm grading your notebooks. And make sure it does get glued in if it hasn't. Today, we are solving rational equations. So rational equations, the word rational comes from the word ratio. Ratios are fractions. These are fractions. See? Yeah? Okay. In a rational equation, we have to solve for two things today. The first thing that we're going to solve for is our solution. And I will show you how to do that in a second with equations like this and how we get the x's out of the bottom of the fraction. But when we solve for a solution, we are going to solve for what x equals. So our solution is what we've been solving for this entire time. Solution is what x equals. Our restriction is what x cannot equal. I'm going to draw an equal sign with a slash through it. So it's what x does not equal. How we solve for our restriction is we're going to take the bottom of our fraction. The bottom of our fraction is called the denominator. I'm going to put a little note to myself. We are always going to set the denominator of our fraction. I'm just going to abbreviate that DENOM. Not equal to 0. And solve. So how we solve for our restriction is we're going to set the denominator of our fraction not equal to 0 and solve. The reason why we have to do that today is because we have x's in the bottom of these equations. So if we have an x in the denominator of our fraction, then we have to make sure that the x in the bottom never equals a number where, what am I trying to say? Never equals a number that's going to make the denominator 0. Because if we have an x down here, and so that's our unknown variable value, if that number that x equals makes it so we're dividing by 0, we're not allowed to do that. So those are called restrictions, or sometimes people call them excluded values. And the reason why we're doing this now is to prepare you guys for the future. So I'm going to actually pull out right now this is what my class of juniors and seniors, this is what they were working on this week. Here's a review we can look at. So they were doing equations like this. These are actually just expressions. But they have to say all of these things that x cannot equal. And so once we get to more advanced equations, which this will not happen in Algebra 1, this will happen in Algebra 2 for you guys. A more advanced equation like this, when we have all these x's in the bottom, we have all of these values that x cannot equal. We are not there yet, but we are going to acknowledge the fact that that will eventually happen in our mathematical careers, and therefore we are going to practice solving for our restrictions now as well. So that's what's on the docket for today. We have to solve for a solution, and we have to solve for a restriction. Any questions right now? Okay, I'm going to go through all of these. And we're going to solve for our solution. Actually, we'll go solution, restriction, solution, restriction. But let's get started solving for our first solution. So we've got 12 over x plus 5 equals 4 here. We're trying to solve for x. And in order to solve for x, we've got to get it out of the bottom of our fraction. How we get things out of the bottom of our fraction is we do the opposite of dividing, which is multiplying. So we're going to multiply both sides by x plus 5. So I'm going to put in parentheses right here x plus 5. I'm going to put in parentheses right here x plus 5. On the left side, those x plus 5s cancel. So I can go ahead and cross them out. So all I have left on the left side of my equation here is the 12. And all I have left over here is 4 times x plus 5. We're going to actually right now flip-flop this because you guys like having your equations with the x's on the left. So we're now going to write down 4 times the quantity x plus 5 equals 12, and that's what we're going to solve. So the x plus 5's canceled. That and that canceled. So we just have the 12 left. It came over here. And then I moved that over there. So all I did was go, whoop. Did you say magic?
Yeah.
It is magic. It's not magic. It's just math. Okay. Then from there we can solve. We know how to solve an equation like this. So that first step is new. But after that first step, we know how to solve an equation like this. We're going to do 4 times x, which is 4x. 4 times 5 is 20. Equals 12. So I just distributed there. I didn't really write it out. So I distributed there. Then from there, I need to get rid of that plus 20. So I'm going to subtract 20 from both sides. I've got 4x on the left. And I've got 12 minus 20, which is negative 8. I'm like zooming in and out of the wrong windows. I'm sorry. And then I'm going to divide both sides by 4. And I'll get x equals negative 2. And that right there is my solution. So that can go on the line that says solution. We put 2 lines here because we're always going to have a solution and a restriction. So we put 2 lines so that you know, remember that you have to do both of them. Okay, any questions about solving for that first one? Okay, the second thing that we have to do is solve for our restriction. So I'm going to do it in a different color. You guys just like in your box, wherever you have space. So I'm just going to make like, you don't need much space. I'm going to make a little box right there to do my other one. Okay, so do it like off. You can like move it to the side. It's literally going to be super small. You can do it in the margin. You can do it down at the bottom and draw an arrow, wherever. We have one more thing that we need to do, and that is that we need to solve for our restriction. So to solve for our restriction, we take the bottom of our fraction. So you have to set up this equation. You have to know how to set this up. You take the bottom of your fraction, x plus 5, and we are going to set it not equal to 0. So draw an equal sign with a line through it, 0. And you solve it just like an equation, but it's like an anti-equation. You're figuring out what it can't equal. And then this one right here is just a one-step equation, because to get rid of that plus 5, we're just going to subtract 5 from both sides. On the left side, we just have x now. Cannot equal. What's 0 minus 5? Negative 5. Yep, so x cannot equal negative 5. So these are the 2 parts of our answer. We need both. This is us saying, this is what our solution is. This is what our solution couldn't be. And so we solve for both of them, because like I was showing you guys on my examples from my functions class, eventually we'll get to the point in life where those will be the same and they'll like cancel each other out. You don't need to worry about that right now because we're just working in one variable right now. But in the future, you might need to. That's why we're worrying about it now, to just like prepare you for it and mention that it's a thing. Questions right now? All right, we're going to move on to our next one. So we're going to multiply by 2x minus 3 on both sides to get rid of that 2x minus 3 in the denominator. So multiply by 2x minus 3. Multiply by 2x minus 3. On the left side, those cancel. So now we've got negative 45 equals this. I'm going to write this equals negative 45. So I'm going to do 5 times the quantity 2x minus 3 equals negative 45. I'm going to solve that out. We will start by distributing. 5 times 2x is 10x. 5 times minus 3 is minus 15. Still equal to negative 45. Then from there, I need to add 15 to both sides. 10x equals negative 45 plus 15. So if I owe you $45, I'm able to pay you 15 back today. I still owe you 30. So that puts us at negative 30. I owe you guys a lot of money, steal a lot of money from you. It's a whole thing. Okay, and then we'll divide both sides by 10. And we'll get x equals negative 3, and that is our solution. X equals negative 3 is our solution. Okay, questions right now about our solution? Wait, we need to solve for our restriction. So I'm going to take my extra space that I still have and split it off here. I've got 2x minus 3. That is the bottom of my fraction. We're going to set it not equal to 0. In order to solve this one for x, since we have the 2 and the minus 3, it's going to be one more step this time. We're going to add 3 to both sides. We'll get 2x equals 3. Or sorry, 2x cannot equal 3. And then we'll divide both sides by 2. The 2's on the left will cancel. And I will be left with 3 over 2. If a fraction does not divide out evenly, and this is going to happen only for your restrictions today, then we are going to leave it as an improper fraction. So our restriction here is going to be x cannot equal 3 over 2. So there's going to be just a couple times where you have to leave it as an improper fraction. And I want you to leave them as a fraction. I want you to leave them as a fraction so much that I put an answer bank on there for you so you knew what fractions they should end up as. Okay, any questions about the two that we've seen? Okay, the last one is actually easier because there's less on the bottom. And so I saved it for last as like a dessert on our notes for today. So we've got 6 over x equals negative 3. We need to get that x out of the denominator. So we're just going to multiply both sides by x. So we'll do x times x. On the left side, those cancel. And so we've got 6 on the left equals negative 3x. And I don't need parentheses because there's nothing to keep in parentheses with the x. So I'm going to flip this around again. It's going to be negative 3x on the left equals 6. And then from there, I'll divide both sides by negative 3. Negative 3 over negative 3 cancels out. That's why we're dividing by it. So we get x equals 6 divided by negative 3 is negative 2. And that is our solution. So we can go ahead and put that on our solution line. Okay. Any questions about our solution? Okay, and then for our restriction, we are going to set the bottom of our fraction not equal to 0. So take that x on the bottom of our fraction, set it not equal to 0. So since the only thing on the bottom of our fraction is x, we can take x, set it not equal to 0. What do we have to do to get x by itself? What is keeping x from being by itself, Brandon? Nothing. There's nothing keeping x from being by itself. So that's why I said this one's easier. Because this one, we had to do all of this work to get x by itself on the bottom there. This one, x is already by itself. So he's already by himself. X cannot equal 0 is our restriction. So we do not need to do any work to solve for that restriction. We can just put it down. So if x is by itself already, then we know that that's what cannot be 0. Because we can't have zeros in the denominator. All right. Any questions right now? All right. Go ahead and glue in your notes to the page after 111. And then Mrs. Garrett and I are coming around with your assignments. We're going to work on our assignments for like 20 minutes. And then we're going to do a task at the board for the last 30 minutes of class. We'll see. Those times are a rough estimate. We'll see how long this assignment takes you. There are 6 problems on your assignment. There is an answer bank. So make sure you use each answer from the answer bank one. There's 2 answer banks, one for solutions, one for restrictions.
How's your day?
There you go.
Good so far.
Winner.
Well, that's supposed to be my run.
Oh, I'm going to stop this recording. Bye, recording.